to TecQuipment Theory of Machines Live. It's not actually Theory of Machines Live, it's Theory of Machines webinar. And I'm joined by Dave Giddings, who is the ICT manager. I've got a little bit of echo in the background that I'm going to resolve for everybody shortly. So Dave, perhaps you could tell us more about what we're going to be doing while I deal with this technical thing.
Well, while you play around with your buttons and your keypad, we're going to be talking about theory machines, looking at where in the real world we see such machines. Then we're going to look at some of our products, and just to give a paragraph on each of the product in that range. Then Dion's going to do a little bit about remote learning support. Then I'm going to jump into ranges overview and just talk briefly about the remaining 8 or 9 product ranges that we have. So that's the plan this afternoon, all providing Dion can remove that echo. Can remove that echo.
I've done it now.
Remove that echo.
Okay, it's done. We're
Good,
okay
sweet.
To proceed.
Yeah, we're good.
Fantastic. I want to do a few shout outs now. We've got Follow That is joining us. We've also got F111 flying solo. Great to see you, and really nice to see you commenting in the chat box there. It's nice to get some feedback. Dave and I are in our home offices, and it could be just us having a chat to ourselves. So getting that feedback is wonderful.
Indeed.
So first of all, I'm going to start off by giving you an overview of the company. Now, many of you watching this today know who we are. We're TecQuipment. We're 62 years old. We're one of the longest players in the engineering education practical teaching industry. In terms of company, we're all about designing, developing, delivering best products for practical teaching of engineering principles, but it's about real life understandings and helping students have the employability for skills that they need tomorrow. As well as those products and all the teaching material that goes with it, we're more than that. We're about holistically assisting in the teaching progress. We like to, we see ourselves as very pivotal in helping bring together the global community of engineering educators. We've got social communities for that. And we feel it's quite important as a player in the industry to help academics motivate students and bring real world connections to the work that the students are doing. And we do that through student competitions. You can find out more about that when I come into that later. Another thing I really want to explain is, as a company, we're all about, when we develop products, bring new products to the market, enhance existing products, we've got 3 very important principles in mind. One is fostering curiosity and sparking passion. And it's really connecting people to the real world. Yesterday, we were doing a Q&A live. We had a guest, Ryan Langdon, and he was talking about his time as a student and how important it was to really connect it to the real world. And that's what we try to do with our teaching equipment and the supporting manuals that go with it. We also build with very much standing the test in time. We don't believe in products that are just going to be here for a couple of years. I'm often talking to academics who have equipment in their labs that go back to the 80s, 70s, 60s even, and they're still in use. A case study from Bradford College is coming out next week, and you can see there how they've got equipment that goes out about many decades that they still use in their labs, along with newer equipment as well. And lastly, we design and develop and build our products with performance for faster, more effective experimentation. What we mean by this is still being able to get all the learning outcomes that are really essential, still have the right level of interaction, but reduce those elements of, for example, filling up a hydraulic bench. Measuring the different levels of water in it, do it digitally. So we try and look at ways that we can streamline and enhance the lab time available. With all of this in mind, we do need to believe in very much simplifying teaching at the same time, integrating functionality that matches the changing syllabus requirements. Now, there may be some changing syllabus requirements that come out as a result of the current health crisis that we need to take into account, and we're very much monitoring and tracking what's happening in the market, what the trends will be in the future, and as an organisation we'll be looking to reflect that. We also look to simplify teaching by providing supporting instructional and theoretical material. It's pretty much there you go, you have everything, off you go. You've got the equipment, you've got the theory, you've got instructions. To a certain degree, in many scenarios, students can self-learn with the material that we provide. Okay, so that's it from me in terms of a company overview. Now, Dave, I'm going to hand over to you. But before I do, I'm looking over at my my chat box screen, and I want to say hi. Somebody, Simon from Make UK in the real world. He is F1 11 flying solo. Simon, fantastic to see you in the UK online with us today. I think you may well have joined us at a recent event we had on the theory of machines as well. Correct me if I'm wrong. I don't remember everybody's name, but if you want to give us some feedback on that, if you did, that would be wonderful. We've also got Omkar Nand Kumar, who's joining us as well. Do let us know what what country you're from as well. It's great to hear what global representation of audience we have with us. All right, I did promise I'd hand over to Dave, and I know you're desperate to hear more about theory of machines and listen to the epic digital Dave. Over to you, Dave, to talk about theory of machines.
Okay then, Dion, so let's just wait for that slide or tab to pop up, then we can make a start. There's a bit of a lag there.
Is it? Sorry, everybody is off their devices. They are hopefully happily playing Monopoly, except for the dog, who shouldn't be playing Monopoly, and neither should the lambs be. Okay. Have you caught up with us yet?
Here we go. Here we go. This is what we're really here for. So we're going to be looking at theory of machines. I don't need to read all of those paragraphs, but basically an understanding of how machines work is absolutely important in engineering courses. We look at engineering science, deals with the study of motion, etc. And our range covers mechanisms, vibrations, gears, cams, forces, and friction and bearings. But what is actually theory of machines? How do we define theory of machines? Well, in my opinion, it's a branch of engineering science which deals with the study of motion between various parts of a machine and the forces which act on those machines. So this knowledge of this subject is very essential for an engineer, whether he's designing various parts of a machine. So that is what theory of machines is. Okay, so if we can look at in the real world, where do we see theory of machines? And I mean, we can just pick a good example where we have a helicopter. There are a number of components relating to theory of machines in just a standard helicopter. We have centrifugal force. This is being generated by the rotor blades. We have drive shafts that are transmitting the drive from the engine to the rear rotor and the main propeller. And we have, like I said, also the drive shafts. They can be studied by whirling of shafts. Now, these are all key words that we will see in our products later on. So we have centrifugal force, we have drive shafts, and gearboxes also. I mean, the main purpose of a helicopter main gearbox or transmission is to reduce the output RPM of the engine to a level that's suitable for the main rotors and tail rotors of a helicopter. For example, a helicopter may have an engine output RPM of 6,000, but we only need a rotor at 300 RPM. So that's where the gearboxes fit in. So that's a broad example of where our range fits in on a helicopter.
Brilliant. Thank you, Dave. Okay, well, I guess you want to talk about, so let's get to the details now, the theory of machines itself and the practical teaching equipment that can support everything that you were talking about with
Yeah.
the helicopter. And I think
Yeah, well, this
one
is a
element
good
is that
example.
Gearbox, isn't it?
Yeah, I mean, I just plucked a picture of a gearbox off the web a few months ago. But even just with a simple gearbox, our range of theory machines covers gears, we have bearings, we have shafts, balancing, there are forces in that gearbox, and there are vibrations. So a gearbox really does typify our range of machines there.
And now here's some more details. Once we've caught up, I really do need to get a faster hamster.
It's catching up slowly. So here we can see three of our ranges, three of our products from our range, starting with the geared system on the left hand side. That's the TM1018. We can study dynamic and static experiments on geared and other drive systems, obviously found in the gearbox itself, but also on the differential on a car, for example. The differential is designed to drive a pair of wheels whilst allowing them to rotate at different speeds. So we are looking at all different aspects of gears and drives on the TM1018. Then we can go to the static and dynamic balancing. We have spoken a lot about this in our Instagram and YouTube live yesterday. Balancing in any engineering, it reduces internal loads and vibrations that normally stress metal, and this would eventually lead to a component failure. Okay, so we are able to observe that statically balanced for low speed and dynamically balanced for high speed, and engineers need to know the difference between the two and the advantages. Okay, so if a drive shaft or if any shaft is statically balanced, it will stay in any angular position without rotation. If a shaft is dynamically balanced, it can be rotated at any speed without any vibration. And we are able to absolutely demonstrate this with the TM1002. And then finally on that slide, we have the centrifugal force, TM1005. This is a rotating assembly with sensors, and it is used to create and measure centrifugal force. So we create and we balance forces on that arm. Like I said, the arms are balanced, so only the force measured and are the weights applied. So we prove imbalance, and we can prove out of balance on the TM1005. Okay, and you've already jumped to the next slide, so I'll try and keep up. So it looks like we've got a gyroscope there. So with the direction of the gyroscope couple in relation to the precession and rotor spin directions. So we've got a rotor and we've got a precession motor. And with that, we're able to actually calculate the gyroscopic couple. Okay, couple. In other words, torque. That's another word.
Dave, before you go too far, I have got a question.
Yeah, sure.
And I might be a little bit behind, so it might be relating to a previous question.
Okay.
But the question is, will these three measure any torsional stress? I think we might need to go back to a previous slide on that.
Any of those three equipments on the previous
three
page?
Measure torsional stress. I'm not exactly sure which one. Perhaps have we got any other pieces of equipment, in fact, that measure torsional stress?
Well, we're getting into possibly we're moving into strength of materials there, Dion.
Right. Okay.
Where we deliberately concentrate on like an SM1001, where we deliberately look at torsional stress and strain on specimens. That's specific. We also look at it on the other torsional pieces of equipment. But for me, the SM1001 is the obvious
And that's the
choice.
universal testing machine we're talking about there.
The SM1001 is the benchtop torsion testing
Oh,
machine.
yeah, sorry, get my product codes right.
Yeah, so we're twisting.
Right.
Yeah.
Okay.
If the chap wants to expand on that, we can do that later in the show, or
Yeah, he's just explained that he's looking specifically at material failure, so I think you've probably covered that for him there.
Well, definitely the SM1001 for sure.
Okay.
At the end, maybe you can pop up the data sheet for that at the end of this.
Let's come back to that one. Yes, SM1001 torsion testing. Brilliant. We will cover that at the very end. We've got so many people putting their comments in there. We've got people from Ecuador, Bolivia. We've got people from across the UK, Coselli University, Shrewsbury, Oxford, Exeter. With many. So it's fantastic to see people joining us today.
It's a who's who today.
Yeah, and it's wonderful to see you putting comments and saying where you're from in the chat box. Thank you for that. Right, Dave.
Okay.
So I derailed you somewhat. Let me get you back on track.
That's what I'm here for. I'm here to be derailed. Don't worry about that. So I was talking about the TM1004, where we look at the couple generated. That's torque, in other words. We are also able to look at the magnitude of this gyroscopic couple in relation to the precession and the rotor and the spin velocities. So yeah, that's a busy piece of equipment there.
In fact, we did a video on it published last week on that particular piece of equipment.
Indeed, so, you did. Yeah.
People could go and have a look at the YouTube channel and look at the latest videos, and you'll find the gyroscope in there. Yeah.
Moving on to the middle product, that's the TM1022. This is studying the primary and secondary forces that exist in a 1, 2, or 4 cylinder engine. Okay, so we look at all the forces and the strains that are occurring due to that piece of equipment, and we are actually able to adjust the angle of the crank by taking the cover off. So that's a very dynamic piece of equipment there.
I really like that piece of equipment because you can take it down, can't you, to remove some of those, what do you call them again? I should know off the top of my head, different elements. It's a really visual experience for students as well.
Extremely visual. Being an ICT guy, it's quite a challenging piece of kit to install because it needs to be mounted on a very heavy bench. It's got a very low frequency. So a granite bench would be ideal, or a bench of about 4 inches thick or 100 millimeters thick, because of the huge amount of torque and force that is being generated. But yeah, I've installed a few of those around the world successfully. Yeah. And then
Birmingham City University, we've got, I think in their video case study, they might feature one of those in that one.
And in Bradford University as well. That was the last one I installed, I think, in Bradford, which I think is on the case study that you
I believe it is. We'll come and talk about that, won't we?
And then finally, we have the cam analysis machine, the TM1021. So a camshaft is the element of an engine that enables the valves to open on your engines. So that's your exhaust valves and that's your inlet valves. Okay, so as the shaft rotates, those egg-shaped cams push the valves open in sync. So that piece of equipment is specifically looking at cams and followers and how they operate and behave in an engine. And moving on to the next slide, the journal bearing apparatus, which is a tall piece of equipment, about 2.5 meters tall. In engines and transmission, there are journal bearings, okay? And this is where the shaft is actually supported by a very, very thin film of oil. Even when the shaft is not rotating, there is a blanket, if you like, of oil that's supporting the shaft. So we look at the principal use of journal bearings in automotive applications. For example, like I said, on a crankshaft, or in some cases actually on a camshaft. So that's an interesting piece of equipment. And finally, we've got the whirling of shafts. And I mentioned where this is relevant on the helicopter, but it demonstrates that whirling at different speeds and conditions. So we would see that on prop shafts, we would see that on drive shafts. Just to remind everyone, a drive shaft is a cylindrical shaft that transmits the torque from the engine to the wheels. And the drive shafts are the same. The prop shaft runs the length of the car and drives the rear wheels, but the drive shafts transmit drive to the front wheel. So there's two drive shafts. Now, whirling of that drive shaft can take place. I'm going from memory now, and I hope I get this right. If the viewers could think I'm saying something a little bit inaccurate, please write a comment. But this whirling of the shaft, it's a resonance vibration when the rotational speed is equal to the natural bending frequency. So that's quite a lot to take in there, but that's the concept. So we're actually able to observe basic whirling demonstration on the TM1001. We can look at the effect of the shaft length and the diameter. We can also look at the effect of changing the end conditions. In other words, the fixings, the way the shaft is actually fixed. We can actually load the shaft with one or two different masses, and we can deliberately perform eccentric loading. So that's a very busy piece of apparatus, the TM1001, but very important that engineers know and appreciate what damage can be done really in the real world. Dion.
Thank you, Dave. Well, talking about the real world and talking about around the world, I wanted to spend a few minutes talking about a few case studies. You've worked with various of these universities. We have specifically got UK universities here, but Theory of Machines equipment has been installed in many universities and colleges around the world.
Indeed, they have, yeah.
First up, shall we talk about the University of Lincoln? Have you been there?
Yes. You've been there more recently, but I went there probably about 3 years ago to install their subsonic wind tunnel. But equally, they did have some other equipment. Now, you caught me out here because I can't remember exactly what equipments they have, but it was more than just the wind tunnel.
It is. They've got statics equipment there, but they particularly, when I asked Dan at the very end of our filming session, I said, Dan is the lab technician there at the University of Lincoln. What is your favorite piece of teaching equipment? And he said the static and dynamic balancing.
Yes, I know. It's such a simple piece of equipment to look at. But it teaches so much about balancing, when I described it earlier. Dan is ex-RAF, I believe.
Yeah, I think he might be.
Yeah. So
sorry, Dan, if you're watching and we don't know the facts.
No, Dan's forgotten more about aerodynamics than I know. So yeah, he taught me a lot, and he's got a fantastic lab set up in Lincoln. So
well, people can watch that. We do have a case study that looks around their labs. If you want to see how different pieces of equipment are used at a university, I would recommend checking out the University of Lincoln's video case study that you can find. And you can search that on our channel or find the case studies tab. Let's now talk about the University of Bradford. I've not been there, Dave.
I
Yeah,
have
they've
been
got
there.
multidisciplinary lab, I believe, at the Faculty of Engineering and Informatics.
Yes.
They've not got lots of theory of machines, but many other things. But they did mention
No,
geared systems.
they've got vibrations, they have materials, and they have some theory of machines. So good spread of equipment there. Again, it's about 3 years since I was there, but that install took a good 3 days given the quantity of equipment. So a very worthwhile visit to do a showcase, which is what you've done. So yeah,
Brilliant.
we have
Okay.
good relations there for sure.
I just want to do a quick shout out to Sunday B from Bedford College, and they're doing construction and civils in his particular department. We do have a case study coming up next week from Teddy Kai Nyarko from Bedford College. So do check
Fantastic.
out on the YouTube channel. We've just had it approved today, so I'm looking forward to sharing that with people. Let's have a look at Northumbria University now. You've been there, as you could see all those wonderful pictures of you, Dave.
Yes. Oh, they've got a plethora of equipment there, including pumps. I mean, I think they've pretty got almost every discipline and every product range. They have some TecQuipment there, so a good spread. For memory, they have a GT103, and they have a flume, they have structures, they have modular fluid power. Looks like that's me there actually in some pictures looking at some equipment. Theory machine. So yeah, again, a good spread of equipment there, Dion.
Nice geared system
Yeah.
up there. Aston University now, and this another one. They had a massive, well, not a massive, a significant order. I think there were about 20 static and dynamic balancing apparatus.
Wow.
The Ujier there, the academic there, he joined Aston University more recently, and they were doing their dynamics course, and it was just theory. So he came in straight into Aston University and really lobbied for these pieces of apparatus. He'd used TecQuipment and the static and dynamic apparatus before going to Aston University, and he has a whole lab full of them. And in that case study, you can see how he's set it up so it runs smoothly, and when it doesn't run smoothly.
Again, you've been there more recently than I have, but I have been to Aston. That's right in the centre of Birmingham, if I remember correctly.
Yeah, absolute nightmare for car parking.
Yes, well, I caught the train. I got the train, Dion, so I was okay.
I couldn't with all my film crew, film gear stuff. It was a traipsing across the town job.
Can imagine. Yeah.
All right.
Okay.
Brilliant. So that's the case studies. Again, everybody can watch the Aston University case study there. Have a look at the static and dynamic balancing apparatus, among many other pieces of apparatus that they utilise there at Aston University. So that brings us a close for focusing specifically at the theory of machines. But we have more. We have lots more.
We do.
Dave, in a few minutes, is going to come on and talk about the other ranges of teaching equipment. If you are teaching beyond theory of machines, you'll want to stay on the webinar for that. I'm now going to quickly talk about remote learning support. It's a really difficult time at the moment. Many people maybe still be in lockdown, or students not able to go into the university or colleges. More and more people are thinking about how do we deal with the current remote learning situation, and how do we prepare for some ongoing remote learning for students. So at TecQuipment, one of our big priorities during this time where we've all been sent to our home offices is how can we support you with that, and doing these webinars is one of those, and remote learning by bringing together communities is another thing. So we have communities on LinkedIn and Facebook, specifically for academics here, so that you can share ideas and thoughts. And they're closed private groups. And if you're not already a member of the Practical Teaching in Engineering Education community groups, then I'd encourage you to search them out, even if you just sit and lurk in the background and observe discussions. It would be great if you want to engage in there as well. We also have a community on YouTube now which students can access as well, but it is open for all. We share videos, not just our videos, other external content on there, and we'd encourage other people to get involved, post polls, things like that as well. So bringing together online community is one thing. The other thing is providing resources. We're trying to do this in multiple ways. One of them is delivering student experiment videos. Once a week, you should get a different student experiment video, which is released. You can find many, many student experiment videos on our YouTube channel. And it's actually students using the apparatus, proving theory. And many of these are from students from Nottingham Trent University who entered our either 2019 or 2020 student competition. We've also provided on YouTube a tips video. If you are looking, if you're allowed back in your lab, or you're looking at being able to go back into your lab soon, but your students aren't, that is, and you still want to deliver some practical teaching element by utilizing the equipment that you've got in your lab through video, this is a really helpful video that we've created that gives you top 9 tips for helping you create a video. Things like lighting, sound, how to capture it on your phone, free editing platforms, etc. So do again have a look on the YouTube channel for that. And then we are delivering every Wednesday live Q&A sessions. We've got Dave. We often have a guest on there as well. Yesterday we had a guest, an electrical engineer, talking about what he likes about being an engineer and his experience as a student and things that he felt worked in his learning experience and things he felt that academics could do better. So that's an interesting perspective if anybody wants to check that out. The week before, we had the Dean and President of Teddy London, a new university that's being set up all about project-based learning, not using traditional lectures, but using a learning tree, accessing content as and when they need to go through an element of an engineering project, working with communities and industry on that. The week before that, previous ones, we've had clinical psychologists helping with how to deal during COVID-19. We also had Dima Nasser, a female engineer from Lebanon, talking about her experience being a woman in engineering, particularly some of the challenges in Lebanon itself, and some kind of inspirational thoughts for females who may want to pursue a career in engineering. If you want to find out more about all of those, we have an area on the website, which is, as you can see right here, not there, sorry. It is www.TecQuipment.com/remote-learning support. A bit of a mouthful, I know, but you could just search it on our search box on the website to make life simpler. Okay, I'm going to take a breather and hand over to Dave, who's going to give you a bit more of an overview of all of the other ranges that we offer. We're going to make this quick though, so let's fire away, Dave, over to you. And I think the first one is engineering science, if that's what you want.
Yes. Okay, well, I'll just wait for the tabs to appear, but I can start talking. There we go. Yeah, engineering science, good introduction to engineering. There are 18 modular experiments covering subject matters such as moments, friction, cams, and tensile. All these experiments sit on a work panel, either in portrait or landscape configuration, like you can see on top of the workbench there. Okay. So moving on to fluid mechanics. This is an extremely extensive range of high quality fluid mechanics teaching and lab equipment. Incidentally, TQ were the first company in the world to offer a modular range of equipment for fundamental studies of fluid mechanics. We have practical fluid experiments available for just about every fluid mechanical course going. So a huge range of equipment there. Engines, yeah, one of my favorite subject areas. We have internal combustion engines, so single cylinder 4-stroke engines, so using gasoline or petrol and diesel as its fuel. But also in the engines, we also have 2 gas turbines, actually 3 gas turbines. We have a GT100 turbojet trainer. Then we have the same but with afterburner or reheat, the RS. Then the GT185, we have the other type of gas turbine. So yeah, it's a 2-shaft gas turbine. So a wide range of engines in our range there. Okay. That looks like control engineering. It's just about appearing on my screen there. We are looking at control engineering principles in this range. So we offer fundamental and advanced investigations into control principles using actual applications that you would find in industry. For example, the ability to control aircraft and ships. All of our CE range, or control engineering range, it comes with our specialist CE 2000 software. This can be also used to simulate controlled experiments. And in the same family of equipment, we then move on to process control. This again demonstrates the fundamental and advanced studies into real-life processes. Includes PID, for example, and cascade control of pressure, flow, temperature, and level. And again, we have dedicated software developed by us at TQ to support our process range. And now for something completely different, the electrical power range offers advanced technical teaching and training equipment for all elements of power systems. That includes generation, transformation, transmission, distribution, utilization, and protection. So these scalable products provide a real hands-on learning of power systems with the options of hardware and software additions. For example, that could be a second generator or the SCADA system. Okay, so that's power systems. And what's next?
It is materials testing. Sorry,
yeah,
I wasn't sure whether it caught up.
Well, I've just for the viewers, I've no idea what's coming up next. So I'm winging this. Okay, I'll be honest with you. That's the best way. One of my favorite subjects, because we actually deliberately break things. Okay, but we look in the materials range into the properties of the material, and the testing of this is a fundamental part of engineering courses. It's a completely comprehensive range covering tension, compression, impact, stress, strain, hardness, and structural experiments. So a wide range of subject areas there. All this is supported by our VDAS automatic data acquisition system. And EC, environmental control. The environmental control range offers teaching equipment covering the fundamental theories associated with thermodynamics, fluid mechanics, and heat transfer. So we've got cooling, we've got refrigeration, we've got air conditioning, and we have humidity, all under that environmental control umbrella.
And we do have a really exciting new product coming up in the near future for that range. Do watch this space. Can't say anything more than that, but nope. It is exciting.
It is too. Yep.
Thermo now.
Thermo, or thermodynamics, as we know it. So this is small scale equipment used for experiments to investigate the laws of thermodynamics. Okay, So again, we've got real working systems using industrial components and assemblies. Now, I've already spoken about gas turbines, but the GT range of our turbines kind of falls under thermodynamics as well. And also the engine test sets kind of fall under thermodynamics as well. Okay.
Here we are with structures.
Structures range, yeah. So again, we TecQuipment are a market leader in the range of modular structures experiments. So it includes static fundamentals experiments and 19 structures experiments. The hardware can be used as standalone, or with the STR2000, it can act as ADA, so automatic data acquisition. But equally, we can do virtual experiments, so where you don't actually need the hardware, you just need the software, but you can perform all 19 experiments. Ideal for classroom demonstrations on projector, and because it's a virtual experiment, you can actually expand the learning outcomes, because we can go beyond the elastic limits. For example, we can deliberately break things in the virtual software because nothing's going to get harmed. So a real powerful range there. So in fact, there's 3 methods for collecting data then on the structures range. Okay, that must be VDAS, Versatile Data Acquisition System. This system was designed by TecQuipment to work across a multiple range of products. So the software itself is free of charge, but then you would need to purchase the hub to make it work. It's designed for ease of use and understanding the principles. There are many user-friendly features, such as the option for large displays, and we have user selectable options for analog and digital displays on that software.
It's probably worth mentioning that some of our products, increasingly, we're integrating VDAS into the hardware of the product, so you don't have to buy a separate unit. Of course, if you've got a separate unit, then you can interchange it between different pieces of apparatus, so that you get more out of it. In some situations, I'm sure many people have seen this, that universities might connect their VDAS screen up to a huge TV screen. We've got a little clip of a team of academics and students from the University of Derby working on an engine no, it wasn't an engine test, I think
gas turbine.
A gas turbine, yeah, and they've got a massive TV on there. It's a touchscreen TV as well, so they can properly interact with it there. That works really well.
It was about a 65-inch screen, I think I remember.
Yeah.
It was super impressive. Yeah,
Yes.
I was very jealous.
Yeah,
they've got of that.
And they have screens rigged up to their flume as well, with cameras in it, huge screens, really to make the most of the visual experience and the data that they can capture.
It puts you almost inside the flume. It's fantastic.
It is phenomenal, isn't it? Right, solar now. The sun is shining.
Yeah, so the solar energy range offers teaching equipment looking at the core principles of solar energy. Okay, so we have PV cells or photovoltaic cells. We have a flat plate solar thermal energy collector, which is what you see in the middle there. We have focusing solar energy collectors. So students can learn all about the efficiencies and the limitations of solar power.
Brilliant.
Yeah.
The next one is aerodynamics. Dave's favourite subject. And this is one where we did a webinar last week, isn't it? So they can always go back and see more detail on that.
Yeah, we have a range of wind tunnels looking at subsonic wind speed through a working section, moving on to our supersonic wind tunnels, So the AF300 intermittent, the AF302 continuous. Also, we have a benchtop subsonic wind tunnel, which is compact, convenient, small scale models, looking at lift and drag and weight traverse of 3D models. Then we also do a flight demonstration wind tunnel where the user, actually gets to fly a plane. So you can look at the stalling, the flow separation, center of gravity, the altitude, attitude, wind speed in knots. So a very wide range of equipment in the aerodynamics section.
We've already done theory of machines. So that brings us to the close on the ranges overview.
I think it probably does. Yeah.
Okay, don't go yet, everyone. Hold on, hold fire, because we've got the Q&A section coming up shortly, and we'll come and we'll go back and look at that torsion testing apparatus for Simon as well at the very end. And any other questions, I'd like to say a special shout out to Nova Didacta in Brazil. We've got many people from their team online today, and we're really pleased that you are finding this so useful.
Yes, I've had some good experiences and some great install jobs with Nova Didacta for sure.
Wonderful. Earlier, I mentioned that we very much see ourselves as a holistic partner in teaching. One of those is through the delivery of student competitions. Now, we every year run student competitions. This year, we opened it up to anybody who wants to get involved. There's a deadline of saying you need to be involved by the 27th of April or 6th of May to announce the winners. Those deadlines, frankly, are out the window with COVID-19. So we are still open to talking with universities and colleges how we can get involved in student competitions. When students can go back into the lab, this is the time that you want to be making the most of engaging them. I guess they'll be hungry for getting hands-on by that point. And these student competitions would feed in really well with that. The idea is that working with universities and colleges, we can run institution level competition. So within your university and college, we can run a competition to prove or experiment with a piece of theory using a piece of TecQuipment apparatus. So you've got to look at the theory, test the theory, do your analysis, draw your conclusions at the end, and create a video up to 5 minutes long. So it fulfills many objectives. We deliver prizes in terms of money and trophies, so extra motivation for students. They get something really tangible to keep with them as part of it, that video that we share on our YouTube channel. And this is where we're getting those student videos from. We're getting those student videos from the competition entries. So it's got many dual purposes. It helps the community as well in terms of you having content to share with your students. If you're interested in getting involved in that competition this year, next year, forget the deadlines, we're open to discussions. We're being flexible, so do contact me, dionknowles@techquipment.com, or just reach out on any of the social media platforms and you'll get through to me to discuss that. We can work with academics who've already done it in the past and can share their experience as well. And as part of that holistic partner in teaching, we also think it's really important to help share insight, gather information from the industry. And that's why we did a study in 2018 and 2019, where we looked at the perceptions of practical teaching in engineering education, how important it was for the likes of employability. So, for example, 90% of academics, and we surveyed over 100 academics from around the world, believe that practical learning is extremely important for student employability. And again, we'll be looking interesting to see how all this pans out when everybody comes, when measures are relaxed after we progress with the situation with COVID. There are many other interesting findings in that report, and you can find that on our website as well. Okay, now is the time for the Q&A. So get ready, everybody. Submit your questions to Dave. I'm just looking over here at my question board.
Anything?
Anything. Well, I've got to
Anything?
remind everybody, come on, jump into action. This is your time. So, Dave, I'm going to ask you a question. If I want to have an overview of the understanding of vibrations in machines, where would I start?
Well, if you want to look at vibrations, then we have to start looking at the TM1016. This offers a good, broad understanding of free and forced vibrations. Then we can possibly we can go into the more modular approach, so the TM16 asterisk, so the 164, 165, 66. So that looks at pendulums, oscillations, trifilar pendulums. So a good range. The TM range would be an ideal start for vibrations, Dion.
Okay. And where would I start with motion?
Oh, well, that's a pretty broad subject
I know.
there.
Well, I guess, could you start with, have we got stuff in the engineering science range, which brings us...
I would think, yeah, I mean, you know, believe it or not, I've barely had any exposure on the ES range, because for the most part, customers don't need the use of an ICT person to install, because there's basically nothing to install. But in motions, yeah, we look at, I'm pretty sure motion is covered somewhere.
Well, you know what? The video that I shared yesterday that I've been working on in my dining room this week on the friction and inclined plane pit. That okay, that's the degree of motion. It's more about understanding friction, but it is moving.
It's friction on an inclined plane, so there is some movement there.
Okay, let's go back now to, I think it was Simon's question. He was talking about torsion testing. Let's have a quick peek at.
I'm sticking with my SM1001.
Right, okay.
It could be moving into like the SM1090, which is the rotating fatigue machine.
Okay, let's have a look at that.
It's possible. I think we need a little bit more information on the subject matter.
Talking about the rotating fatigue machine, this was interesting. We were talking about this in the Q&A live yesterday, that this is, you can have experiments that run up to 72 hours long on this, isn't it? So it's really about long duration testing, and that's where VDAS really comes into its own.
Oh, for sure, data acquisition. You can't really do this without VDAS, because let's say we're using a mild steel specimen with no load at maximum speed. This could take days to show fatigue and eventually break. So you need the VDAS to record the cycle, number of revolutions, and the load. Then when the specimen breaks, everything switches off. The machine switches off, so it's very safe to leave over a period of time, and it's actually designed to be left over a period of time.
Okay. All right. We were talking about creep as well yesterday, weren't we? The creep testing, which is related to that. Yeah,
there's a bit of fatigue there. The creep, we are looking, well, we subject the specimens to a tensile test, whereby we apply a weight, we apply a load, and over time we watch the specimen creep. Okay, so we do that by, like I said, applying a load. There's a small mitutorio gauge buried in that picture that's measuring the deflection of the specimen. So over time, we see three phases, if you like, of creep. So that's a primary, a secondary, and a tertiary. And we can use different specimens. So we have lead specimens, we have nylon and polythene. But if you're wondering what that blue ice block there is for, it's not being left there accidental on a picnic. We actually have a little environmental chamber, if you can see.
Oh yeah,
underneath that perspex
area.
Well, that's where the specimen is, but just by changing the temperature in that chamber, we see a different effect on the creep. So the time to failure, for example, and that sticking out of that chamber is in fact a thermometer where we can actually observe the temperature change due to using that ice block.
Oh, brilliant. Well, Simon's actually come back and clarified. He said he's talking about covering material failures as part of HNC materials unit, and an LO4 covers all material failures, done tensile testing, etc. But learners rarely see torsional failures, creep and fatigue are easy to show. So it's rare. How do you really see torsional failures in a very
Yeah,
visual way?
I was right about the SM1001. We have a range of different specimens made out of steel, aluminium, and brass. First of all, we look at a simple torsional experiment, which is load. So load applied on one axis of the graph against angular deflection on the other graph. So we can load a specimen through its elastic region via a hand wheel, and then we can observe the angular deflection in degrees and plot our classic Hooke's law graph. So we have our elastic region. We then have the yield point where it goes from elastic to plastic. Then we go and count into the plastic region. So we can see the full cycle, if you like, from load over extension. But then it gets a little bit more interesting because we can introduce what's called a torsiometer. And that allows us to measure very small amounts of creep on that specimen. That means we can actually look at more detail in the elastic region. So we're going to be looking at the straight line part of the graph. Now, if we got the straight line of the graph, for example, in Excel, where we've exported the data, we can actually then calculate the Young's modulus. Okay, all we need to do is use Excel or some graph paper, work out the gradient of your graph, and that will tell us the Young's modulus. Now we can also calculate the Young's modulus because we know the stress, we know the strain, we know the force applied, we know the material type, so we can therefore calculate Young's modulus and also show it on our Excel graph. So I think that piece of equipment would be ideally suited for Simon.
Great. Simon has said instructional manual replacements, question mark. What would you...
Does that suggest that Simon has got missing manuals, or I'm not sure how to interpret that in question.
Okay, I think he's saying it's exactly what he's looking for. So I think I think he's found what he needs. That's great. Good. Simon's got there. Good. Right. Well, last chance for anybody who's watching this live now to post your comments, post your questions in the chat box, and I'll put those to Digital Dave. Now, I want to quickly skip back to our Prezi now. I'm not sure whether we can yet see that.
Not yet, but it's on its way.
Make sure, I think I have to, let me skip my screen. There we go. Go back to that. We have got another webinar coming up. Given that these webinars are proving to be so popular, we are planning to do more. Next week, Dave and I will be back and we'll be talking about fluid mechanics.
We will, indeed.
Yeah, so you can join us on May the 21st at 1 p.m. BST, exactly the same time as today. You can set a reminder for that. It isn't quite listed in YouTube, but it will be very, very soon. if you want to go back and look at previous webinar, you can check out the aerodynamics one that we had last week. And we have a live events playlist. If you look in that playlist, you can see all of these webinars. You can see the live Q&As. You can also see the live events that we actually did in the factory earlier this year and last year, where we were using pieces of apparatus live in a kind of live event platform. So I'd encourage you to go and check those out as well. All right, thank you for everybody for their wonderful feedback during this session. That wraps us up for today, unless you've got anything else you'd like to add to that, Dave.
Yeah, well, in my capacity as ICT manager, installation training manager, if any customers who are watching in the UK that have had equipment decommissioned during this lockdown and have found that you want to start considering recommissioning, then please contact customer.care@, and we'd be happy to give you all the support virtually, or even after a risk assessment, we would consider coming to you and just doing an inventory and making sure everything is working fine. So just consider that and use us as a resource to get you back up and running, safety permitting, of course.
Talking of decommissioning, we covered that as a topic on our live Q&A yesterday. So if
did.
anybody wants any particular tips and guideline on that, go and check out the live Q&A session on the live events list from the 13th of May. Also, you know, Dave, you've mentioned that UK people, but we are available as customer care to everybody around the world. It might be that we can't actually come and see you right now, but we can do a whole lot remotely, as we've proven over the last 8 weeks through these live Q&As and webinars. So we're here to help you.
We are indeed.
On that note, that wraps us up for today. Thank you so much. You can feel free to share this with other people. They can watch it on demand using this very same link, and join us again next week. If you're not already subscribing to the TecQuipment YouTube channel, if you do, then you'll automatically be notified when we do go live. Thank you very much, and thank you, Dave.
Thank you, Dion, and thank you everybody for taking the time to watch.
Thank you and goodbye.
Bye now.